Good morning, students. In today's class, let us continue with the miscellaneous exercise remaining problems. We are revising actually the entire chapter. So, we completed till fourth question. Let us see the fifth question now. Now, what is given in the fifth question? Show that if A is a subset of B, then C minus B is a subset of C minus A. As we were solving many problems, I told you if we want to prove one set is equal to the other set, then you have to prove that particular set, each is a subset of the other. In such a way, if we prove, we can conclude that one set is equal to the other set. Similarly, how will you prove one set is a subset of the other set? Start with an element from this set and try to prove that element is there also in this set, then automatically this set will become a subset of this set. This is the way to proceed a problem, right? So the same way we are going to proceed this problem. Here they have given A is a subset of B. So we have taken an element from C minus B. Then what is the definition of C minus B? The difference of two sets, which says that particular element belongs to the first set and it does not belongs to the second set. That is what the definition of a difference of two sets. So X belongs to C and X does not belongs to B. But A is a subset of B, right? Which means all the elements of A are in B. All the elements of, understand my words, listen to my words properly. All the elements of A are in B. If an element which is not in B itself, then how it will be there in A, right? All the elements of A are in B. If an element which is not in B, then there is no possibility for an element to be available in A. Therefore, X does not belongs to B implies X does not belongs to A, since A is a subset of B, right? So if an element belongs to the set and it does not belongs to the second set, then it will be in C minus A. Thus we started with an element in C minus B and we ended saying that same element is there in C minus A even. Therefore C minus B is a subset of C minus A. Hence we proved, right? Now let us move on to the next question. Assume that P of A equal to P of B. Show that A equal to B. We need to prove two sets are equal. What is P of A and P of B? P of A is power set of A. P of B is power set of B. What are the elements will be there in a power set? All the subsets of that set, right? So power set itself is a set which consists of all the subsets of the particular set. For example, if A is equals to say 1, 2, 3, then the power set of A will have all the subsets of the set A, which means how will you list out the subsets? We will start with the null set and then we will write singleton sets and then we will write all the possibilities with combination of 2. Then we will write 3 elements, thus we reach the entire set. So these are all the elements of P of A. Hope you remember, right? So what is power set of A? It will consist of all the subsets of A. Now it is given P of A equal to P of B. So power set of some set A is same as power set of some other set A. Then they are asking us to prove the set A is equals to set B. Obvious, right? If the subsets are same, then the sets will also be same. Because in P of A, we are not listing out only specific subsets. We are listing out all the subsets, right? So obviously it is true, but they are asking us to prove. How we can prove this? Let us see. Now what we are going to do, as the same procedure as I briefed even in the last problem, when we want to prove one set is equal to the other set, we need to prove this is a subset of this and this is a subset of this. We have to prove either of them are a proper subset of each other. Therefore automatically the two sets will become equal sets. Okay. So to prove it's a subset, what we will do, we will start with an element from one set. So we have started with one element from set A. Now A belongs to P of A. Yes or no? When we are writing the power set, the actual set will also be there, because in the power set we are listing out the subsets and we know null set and the set is the subset of itself. For every set, null set and the original set is the subset of itself. So always that particular set will belongs to the power set, right? But P of A is same as P of B, which is given in the question. Now come back to our assumption, X belongs to A. Now since A belongs to P of A and P of A is equals to P of B, this X will belong to some set C for some C belongs to P of B. Hope you understood what they are meaning here is, see, here we have taken some element from A. So assume I have taken the element 1. I have taken the element 1. Now 1 belongs to some element in P of A. Yes or no? Which are all the elements? This 1 belongs to this element. This 1 belongs to this element. This one belongs to this element. This one belongs to this element. So when an element in A will belong to some element in P of A, whereas if we say element in P of A, each element is a set, right? Each element is a set. Try to understand. So here in the question it is given P of A is same as P of B. P of A is equals to P of B, right? Now we have assumed some element in A, say 1 or 2 or 3, assume 1. Now this 1 belongs to some element in P of B, some element in P of B. This element directly won't apply. In P of A we won't write 1 as a separate element. We will write within the sets. That set itself is an element of P of B. That's why we have denoted it as C. Okay, this X belongs to C for some C belongs to P of B. That C itself is a set, right? Now C is a subset of B. Why C is a subset of B? That 1 belongs to one particular element, right? Now each element is a set in a power set. Now when we talk, how we can compare this with P of B is a element. But how will you compare this set? This set is an element of P of B, but this set is a subset of B. Yes or no? Because all the subsets only we have listed out in the power set. So this set is an element of P of B, whereas the same set is a subset of B. Right? That's what they have given here. C is an element of P of B, therefore C will be a subset of B. Right? Since C is a subset of B, if an element belongs to C, automatically that element belongs to B. Therefore X belongs to B. Since C is a subset of B, if an element in C, it will belong to B. We started with an element in A and we ended saying that the same element is there in B also. Therefore A is a subset of B. Similarly, we can prove B is a subset of A. Therefore two sets are equal. See, all these set theory and modern algebra, all these things are virtual chapters. Math itself is a virtual abstract concept only. So you have to visualize, imagine, then only you can prove it. You should understand, you should analyze, you should imagine. If you are unable to visualize the concepts, kindly take one example, relate the concept with the example, try to understand and then proceed with the problem. Okay, don't think this is very difficult, I can't understand. Don't create such kind of feeling. It is very easy if you compare the problem with one example. If you are unable to understand it, relate it with a numerical example, you can easily understand, right? So I'll brief it again. We started with an element in A, given that the power sets of two sets are equal and we need to prove that two sets are equal, right? So we started with an element in one set, then we know that every set is a subset of itself and every set is an element of its power set. Therefore A belongs to P of A, but P of A is same as P of B. Now since X belongs to A, that particular X belongs to some set in power set, right? So X belongs to C for some C belongs to P of A. When we talk about elements of power set, each one is an element of that power set, but when we compare that with the set only, it will become a subset. So C is an element of power set, but that C is a subset of B. Therefore X belongs to B. Since C is a subset of B, an element in set C will also be there in set B. Thus, we started with an element in A and we showed that the same element is there in the set B also. Therefore, A is a subset of B. Similarly, we can prove B is a subset of A. Therefore, two sets have become equal, right? Next question is it true for any sets A and B, P of A union P of B is equals to P of A union B? Justify your answer. They asked whether is this true for any sets. So I am going to leave it for you. This you can prove by taking your own example. Take set A with some elements as you wish and set B with some elements. Take your own example and find what is P of A, P of B. What is P of A? Power set of A. List out all the subsets of A. P of B, or list out all the subsets of B. Don't forget to include null set and the original set. And try to find P of A union P of B on one side. Other side, first find what is A union B, then find P of A union B. Hope you understood, right? And check out whether both are equal. It won't be equal. So it is a simple problem. Since I asked you to justify your answer, take your own example and try to prove it. Okay, I'm leaving it to you. So you are going to do this problem as homework. Next, we will see the ninth question. We have to show that A union A intersection B is equals to A intersection A union B is equals to A. Right? Understand the question properly. Here we have intersection. If we union the set A with intersection with another set B, you will get the same set. And here, if you intersect the set A with its union, you will get the same set. Alright? So how we can prove this? So as we prove, if we want to show two sets are equal, we will show that one set is a subset of the other, either way, vice versa, right? So we know that A is, now we are going to try to prove that this is a subset of A and A is a subset of this. And we know that every set is a subset of itself, and intersection of two sets is also a subset of one of these sets. A intersection B is a subset of A as well as A intersection B is a subset of B, right? So from these two, A union A intersection B will be a subset of A. So the other way, we will say that A is a subset of this. It is obvious because the set A is there. So obviously set A will be a subset of A union A intersection B. If we union one particular set with its union, then obviously the set A will be available there, right? So it is a subset. So either ways we showed, therefore both will be equal. Yes. Now we are moving on to the second subdivision, A intersection A union B. This also can be proved in this way, but there is a simpler way than this. Since it is intersection, we know a distributive law. A intersection A union B can be written as A intersection A union A intersection B. Distributive law. A intersection A union A intersection B. This is distributive law. So using distributive law, we have written like this. But what is A intersection A? It is nothing but A union A intersection B. Just now we proved A union A intersection B is nothing but A. So we can write A. This is by first subdivision. Understood? Now we are moving on to the next question. Show that A intersection B is equal to A intersection C need not imply B equal to C. If the intersection of a particular set with two another sets are same, then it doesn't mean that the two sets are equal. This can be proved, need not imply. This can be proved by giving your own example. See, I have taken set A is equals to 3 elements. Set B is equals to another 3 elements and set C is equals to some other elements. In such a way, A intersection B and A intersection C are same. In such a way, you should choose your elements. See, for example, here what will be A intersection B? The common elements in set A and set B, 2, 3, 2, 3, right? So 2 and 3 will be there in A intersection B. Now what will be A intersection C? A intersection C. Again 2, 3, right? So 2, 3. Now A intersection B is same as A intersection C. But if you see the set B and set C are not equal sets. When we will call two sets to be equal? If they have the same elements. So intersection are same need not imply the two sets should be same. Hence we proved, right? Now let us move on to the next question, 13th question. The question is, in a survey of 600 students in a school, 150 students were found to be taking tea. Right? We have solved problems of this kind. So in a survey of 600 students means the universal set. That's why I have written n of u is equal to 600. 150 students were found to be taking tea. So we represented the set as capital T. N of t is 150 and 225 taking coffee. So n of c is 225. 100 were taking both tea and coffee. I told you whenever you have a clue like both, it means intersection. So n of t intersection c is 100. What they asked you to find how many students were taking neither tea nor coffee. In the sense, none of the number of students taking neither tea nor coffee. So how will you denote it in notation? Neither tea nor coffee, which means they should not take tea as well as they should not take coffee, right? So we are representing tea by the number of students who are taking tea. So who are not taking tea will be its complement. Similarly, the number of students who are taking coffee will be C. So the number of students who are not taking coffee will be given by C dash. They didn't ask separately. Number of students who are not taking tea, na, it will be just n of t dash. Number of students who are not taking coffee, na, it will be just n of c dash. But they asked together neither tea nor coffee. அவங்க டீயும் குடிக்கக்கூடாது காஃபியும் குடிக்கக்கூடாது. So it will be the intersection, right? So n of t dash intersection c dash, complement of the set t intersected with complement of set c, and the number of students. This will give you the number of students who neither take tea nor coffee, right? So let us see how we can solve this problem using numerically, and I'll explain the same problem using Venn diagram even, so that you can understand it in a better way, right? First let us see how we can solve this numerically. So n of t dash intersection c dash, which is nothing but n of t union c the whole dash. Hope you remember this is which law? De Morgan's law. What is De Morgan told? T intersection t dash intersection c dash, which means a dash intersection b dash is nothing but a union b the whole dash. A union b the whole dash. Now this how we can remember? These are all listed out in the important results related to cardinal numbers. If you recall, you can get it, right? Now t union c the whole dash, how I can write? What is the definition of the complement? Dash means complement. So what is the definition of the complement? It is nothing but the difference between the universal set and the set. So this I can write it as n of u minus n of t union c. But again, t union c is n of t union c is nothing but n of t plus n of c minus n of t intersection c. And kindly put braces since we have negative sign here, or else you will miss out the signs. Now why we need to do all these things here? Why can't we directly find the value? Because the data is given only for n of u, n of t, n of c and n of t intersection c. So we are trying to replace the given question in terms of the known values. Then only we can substitute the numbers and find the answer. So we have replaced everything. If we have complement and all, we don't have the values here. So we have replaced. Now substitute the values. What is n of u given in the question? 600. N of t is 150. N of c is 225 minus intersection is 100. Now simplify and get the answer. 600 minus, what is 150 plus 225? It will become 375 minus 100. So if we simplify, we will get the answer. 375 minus 100 is 275. If you subtract, we are getting 325. So we arrived at the number of students taking neither tea nor coffee, right? Now let us explain how we can solve this problem using Venn diagram. So how will you represent? First, the universal set will be represented using rectangle. And since here only two sets are involved, draw two circles. So this set is tea and this set is coffee. And now the number of people taken in survey is 600. So the universal set is 600. number of students taking tea is 150, so I am going to write 150 here, and n of c is 225, so this is 225. N of t intersection c is 100. But when you are writing numbers like this, you have to be very careful. See, n of t 100, which denotes the entire circle of t, right? This 225 denotes the entire circle of c, which means this 100 is also included in 225. This 100 is also included in 150. This intersection part is also included in 150. This intersection of tea and coffee is also included in 225. Right? So if you want to know the number of students who drink only tea, what you should do? You should subtract this 100 from this 150. Similarly, here if you want to know the number of students who drink only coffee, you have to subtract this 100 from 225. So if you subtract this 100 from 225, what will happen? I am going to subtract this 100 from 225, which is nothing but 125. So 125 number of students drink only coffee. And here similarly, if you subtract this 100 from here, you will get 50. So this 50 students who drink only tea. And what about this 100? 100 students drink both tea and coffee. This overlapping we removed now, right? This 100 is included here and this 100 is also included here. So we removed this 100. Now we got a clear idea which says that 50 students drinks only tea, 100 students drink both tea and coffee, whereas 125 students drink only coffee. Now our question is to find number of students taking neither tea nor coffee, which means the count which does not come under inside this circle, right? Circle kulla irka count gives us who drinks tea, who drinks coffee, who drinks both the tea and coffee, but we need number of students who does not drink tea and coffee. Abdina, the count which is not included inside the circle. Appo what you should do? You should subtract these numbers from 600. 600 is the total number, right? So from 600 you have to subtract all these three numbers to get your answer. So what will happen if you subtract these numbers from 600? Add 50 plus 100 is 150, 150 plus 125 and subtract it from 600. Let us see whether are we getting the same answer. 600 minus 50 plus 100 plus 125. So if you see, if we add all these things, what we will get? 270. I don't have space here, so I have written here 275. If you subtract 275 from 600, we will get 325. So the same answer we got. Thus how we will use Venn diagram in such a kind of problems, and that is the role of Venn diagram, right? So you can solve the problem using Venn diagram or numerical. Hope you have understood the problem in a better way, right? So the next question, 14th one, it is given in a group of 100 students. Okay, in a group of 100 students know Hindi. In a group of students, 100 students know Hindi. So I have represented N of H as 100 and 50 know English. So N of E is 50 and 25 know both. So N of H intersection E is 25 and each of the students know either Hindi or English. So what do they mean by this statement? They mean in a group of students there are none of the students who won't speak either of the languages. அப்படின்னா அந்த group of studentsல எல்லாருமே கண்டிப்பா they will speak one language or both. There are no students who don't speak English nor Hindi, right? So how many students are there in the group? They asked you to find what is N of U. Here N of U is nothing but N of H union E, because there are no students left out without speaking both the languages. So N of H union E is nothing but N of U. This can be easily found out using the relation. What is N of H union E? Which is N of H plus N of E minus N of H intersection E. If you write that relation, result, substitute the values and you can very well get the answer. So the only thing relies in such a kind of problems is you should understand the question and you should know the data. You should know to list out the data. You should visualize it and list out the correct values. Then you can easily substitute and you can find the answer. Here I have represented using Venn diagram also. So, and the denotions also, it is not necessary always you should use H, E. If you want to go with A, B, C, you can go with A, B, C, but before that you just denote it, give the description. Let A denote the set of students who are speaking Hindi, let B denote the set of students who speak English. You just give your description, right? Now if you see through Venn diagram, two sets H and E, speak Hindi is 100, so I have written 100 inside H. 50 speak English, so I have written 50 here. 25 speak both, so I have written 25 in the intersection region. Immediately you should subtract that intersection. Only then you will get the only Hindi part, only English part. Or else if you add 100 plus 25 plus 50, it will give you a wrong result, because this 25 is included with this 100, this 25 is also included with this 50. So immediately you should subtract this overlapping. You should get the separate values for Hindi and English. So if we subtract, we are getting 75 here, 25 here. So if you add students speak only Hindi, students speak only English, with the students who speak both Hindi and English, you will get the number of students in a group. So 75 plus 25 plus 25 will be your answer, right? Now we will move on to the next question. 15th one. 15th one is also of the same kind. So let us see how we can solve this. So 15th question is, in a survey of 60 people, so N of U is 60, it was found that 25 read newspaper H, so I have written N of H. 26 read newspaper T, so N of T. 26 read newspaper I, again 26 people read newspaper I, so N of I is 26. 9 read both H and I, so both H and I, both means intersection, N of H intersection I is 9. And 11 read both H and T, 8 read both T and I, and 3 read all the 3. So H intersection T intersection I is 3. What they asked you to find? They asked you to find two things. Number read at least one of the newspaper, and number of students who read exactly one newspaper. So number read at least one of the newspaper. I told you many times while solving problems of this kind, when you have at least one of the newspaper, it is nothing but the union of all the 3. When you have both, then it means that intersection, right? At least one of the newspapers means you have to find the union of all the 3. So N of H union T union I. We know this relation, we have learnt already. This is just the extension of union of 2 sets. Here we have 3 sets, right? So N of H plus N of T plus N of I minus intersections of 2 sets plus sum of all the 3 sets. We know all these values. So just to substitute here, you will come to know what is N of H union T union I. Don't blindly go with the clue words, but you should understand the meaning also. Number of people who read at least one of the newspaper. So ஏதாச்சும் ஒரு பேப்பர் படித்தா கூட போதும். If they read any one of the newspaper, they will come under the union of all the 3, right? If it is available in any one of the set, when we are writing the union, we will list out all the elements. That's how we are going with the union of all the 3 sets. So behind all these explanations, I am giving you clue words. If you come across the word at least, you should go with the union, right? Now if you see the second question, number read exactly one newspaper. Exactly one newspaper. Problems of this kind, Venn diagram gives you a better hand instead of going with numerically. So I'll explain you how to solve this. So I have drawn 3 circles here because we are dealing with 3 sets. Right? Number read exactly one newspaper, in the sense we need which count? This count. Number who read only Hindi, number of who read only this newspaper T, and number who read only this newspaper I. We need these counts alone. So if you know what is the count of this, what is the count of this, and what is the count of this, if we add all the 3, we will get the answer, right? But in the question, the N of H is equals to 25. By the way, they mean the entire H. The entire H. This includes intersection of H with T, intersection of H with I, intersection of H with T and I also, right? This 25 includes all these 3 numbers even. So you have to be very careful. Your first step, we need to find what number denotes only this, and similarly we can find the remaining two and we can add. Right. So for that, first write the values, known values here. Always you should fill the Venn diagram from the center, from inner part to the outer part. So first, if you know the intersection of all the three, write it here. In the question they have given H intersection T intersection I is 3. So I have written 3 in the middle. Then H intersection T is 11. So H intersection T is 11. So 11 here. T intersection I is 8. Then I intersection T is, H intersection T, H intersection I is 9. So write these three values. So immediately, as I told you, you should subtract this 3 intersection from these 3. So what is 11 minus 3? 11 minus 3 is 8. 8 minus 3 is 5. And 9 minus 3 is 6. Why are we immediately subtracting? If we don't subtract, the overlapping occurs, because this 11 includes this 3. This 8 includes this 3. This 9 also includes this 3. So immediately subtract. Then here H alone 25. Alright. Here T alone 26 and I also 26. Again this 25 includes this 11, 3 and 9. Right. So immediately we need to subtract that from this 25. So which number you will subtract here? You need to add all the 3 and subtract here. What is 8 plus 3? 11. 11 plus 6 is 17. So subtract 17 from 25. Similarly here 8 plus 3 is 11. 11 plus 5 is 16. So subtract 16 from 26. Here 6 plus 3 is 9. 9 plus 5 is 14. Subtract 14 from 26. Now we need to subtract all these values. Then only we will come to know what does the value denote only H. Right. So what is 25 minus 17 is 8. What is 26 minus 16, which is 10. What is 26 minus 14? 12. Now these numbers denote the number of people who read only that newspaper. Only that newspaper. So add all these three numbers. 8 plus 10 plus 12 will give you the answer. Therefore, number read exactly one newspaper is equals to 8 plus 10 plus 12, which is equals to 10, 20, 30. So 30 is the answer. So this is how you can find the answer for any problem. First step is fill in the data in the Venn diagram and then immediately subtract the intersection regions and then proceed with the problem. If you don't subtract the intersection region, you will get the overlapping of the values. It will lead to wrong calculations. Right? Hope you understand. So students, with this we will wind up our class. Do these problems as homework. I have given you clues to solve these problems. So try solve this problem, and if you have any doubt, you just contact me and go through the entire chapter. So from tomorrow's class, we will start with the new chapter and we will be writing test in this chapter soon. Thank you, students.